Mr. Chairman, ladies and gentlemen, it is my great honor to be invited to Tokyo College to be a visiting professor for a month. I'm a little overwhelmed by the distinguished audience sitting here, including the Deputy Minister of Foreign Affairs, Asako Omi-san, and my good friend, Nori Sensei and Mrs. Noyori, and also my wife, who accompany me. She's very important. Today, I'm going to talk about the challenges of science to combat global climate change. And Charles Darwin was born about 200 years ago. He said that it's not the strongest of the species that will survive or the most intelligent. It is the one most adaptable to change. If Darwin were to be here, he certainly would say that the environment is changing so fast. And so the fate of the species who cannot adapt to the evolution, adapt to the change, will be the extinction. And human society are changing so fast, and humans are difficult to adapt to the rapid climate change and rapid deteriorating ecosystem today. So unless mankind slows down environmental change, the fate of extinction cannot be avoided. Charles Darwin probably would tell us this. At the same time, Charles Darwin might say that the problem we're facing is a global problems. Can that be solved effectively by nation-based systems and approaches? I remember in 2004, Mr. Koji Omi established the Science, Technology, and Society. He also mentioned that the border of the nation is just a line on the map. Nature does not recognize all those lines. Actually, toward the end of the 19th century, there's an International Association of Academies that was established in 1899. But in 1914, the start of the First World War, that organization disappeared. After the war, in 1918, First World War was finished. Then there was International Research Council was organized. At the time, humanity realized that we should not keep on fighting. We should work together rather than fighting. So that war is really supposed to be the end of the World War, but that unfortunately they did not realize. But after the war, after the First World War, many scientific organizations are formed. So by 1922, if you look at the 10 scientific unions, 8 of them joined International Council for Scientific Union. There are 10 of them. And in 1931, International Research Council was disbanded, and the formation of International Council for Scientific Union was established. And that organization lasted until last year. Then, ICSU joined with the International Social Science Council and became International Science Council. Actually, many of you probably know Professor Yoshikawa was the president from 1999 to 1902, and he made a great contribution. And when I was nominated to become the president in 2008, I consulted with him, and Yoshikawa-san encouraged me to be a candidate and run for it. So when I took the position as the president of International Council of Science, there were 121 national members representing 141 countries and 30 international scientific unions and 22 scientific associates. But very importantly, there are 17 disciplinary bodies in key areas. And you can see those are the countries covered by International Council of Scientific Union at the time. And there are four regional offices Actually, 3 regional offices. Head office was in France. International Council of Science is a mission. It's to strengthen international science for the benefit of society. Actually, when I was young, when I entered the university, I had 2 goals in my mind. I wanted to be a good scientist, and the other things, I wanted to work with idealistic people to make this world a better place to be. So ICSU's mission is actually that is in agreement with my goal. ICSU do 3 things. One is to coordinate research, program that advance frontiers and underpin like IPCC and other assessment. I remember in 1957, when I was a student in National Town University, International Geophysical Year was established. 98, Sputnik was up in the sky. In the following years, I was part of the satellite tracking team in Taiwan, and still remember vividly the activity of ICSU. And then ICSU organized many programs like World Climate Research Partnership, or on the diversity, there's a DIVERSITAS, International Geosphere, Biosphere, and Human Dimension, and so on and so forth. This is one of the very important things. And also, we engage in policy. So 2012, when United Nations invited us to be the science technology representative to go to Rio Plus 20, we accepted it, and we went to Rio Plus 20. Actually, at the time, we didn't have money. ICSU only depend on the membership to collect the money. We didn't have money. So at the time, the vice president of ICSU and myself went to raise some fund and to attend the Rio Plus 20. The other thing we are doing is engage society. We have workshops, symposia, and conferences, and let people know what we are doing, what are the important things. ICSU organizes programs with many organizations, not by ICSU alone. So you can see that sometimes we work with ISSC, or sometimes with a UN organization, UNESCO, but year after year, we have established many programs like IRDR and IP-based, and that program is organized, integrated, and gradually moved to a future Earth. So you can see that starting from 1980, World Climate Research Partnership and Global really Geosphere, Biosphere program, DIVERSITAS, Human Dimensions, and by the time when we reached 2001, that was the time when President Yoshikawa was the president of ICSU. We have the Earth System Science Partnership organized and discussing all those programs which are related to Earth systems should somehow be integrated. And Yoshikawa-san certainly played a very, very important role, made important contributions. So after 2001, Belmont Forum was doing a similar thing as we are doing in ICSU. So there are 8 organizations work together, including United Nations University, International Social Science Council, and ICFA, UNEP, WMO as an observer. We form the Future Earth Research for Global Sustainability. And the way what happened was ICSU and the ISSC had a visioning meeting in Paris for 3 days. The first day, all the young scientists got together and looked at what should be done. And that was really the most exciting day. The following day, when all the people came, and it was not as exciting as the first day, all the young people with many different ideas. And ICSU, ISSC, together with Belmont Forum, form the alliances and we move forward. And Future Earth, when we announced the establishment in Rio Plus 20 in 2012, we mentioned that this is a 10-year research program on global sustainability. This program is to provide the knowledge required for societies in the world to face risk posed by global environmental change and seize opportunity in a transition to global sustainability. So this is a program really try to move toward the sustainability. In order to change all those existing global systems program into the Future Earth, we do have the transition team. They served from 2011 to 2012. Again, ICSU faced the problem of we didn't have money. So to raise funds to do it. And at the end, they come up with the suggestion that we do have a governance. And the important thing is science committee. We have a governing council, science committee, engagement committee, executive secretary, and try to work on the project. Integration and synthesis on 3 different subjects. I keep on saying that we didn't have money. That was the problem of ICSU. ICSU, when we move on to science committee, again, there's no money. So we have to raise funds. And it's not as easy, but the chairman of Time Foundation provided million after millions to help us getting going. So in the Rio Plus 20, we stated that the Future Earth is a global platform that forges partnership between researchers, funders, and users worldwide, and carried out integrated research across fields and disciplines, generate solutions for grand challenges in the sustainability transition. We communicate science to society and society to science. That was the global platform supposed to be doing. And we also ask big questions. How and why the global environment changing? What are likely future changes? What are the implications for the well-being of humans and other species? What choices can be made to reduce risk and vulnerability and enhance resilience? How can this knowledge support decisions and sustainable development? And actually, Future Earth is different from research program that came before. And how is that different? You look at the theme, research theme is really transforming towards sustainability. And we look at the global development and look at the dynamic planet. There was the 3 important subjects at the time. And you look at the dynamic planet, we look at the approaches, models, and critical zones. There are many subsystems. And you look at the global development, stewardship of resources, ecosystem services, equitable access, and look at the transformation towards sustainability. Transformation process, innovation and ideas, and global and regional governance. And at that time, we are keep on thinking, what kind of regional organization it should be. And Japan, they play a very important role. And the second difference is, this program is so-called co-designing and co-producing research. We find the problem. So many problems, so research definition, we co-design and co-produce the knowledge, and then disseminate the result. So this is somewhat different from the previous scientific program. Those are the ideas, what we had at the time. And the benefit will be relevance, because knowledge and solution that are directly relevant to the needs and concerns of stakeholders and society at large. So in a sense, it's really very different. And difference number 3 is mobilizing regions and nations. We didn't know at that time what kind of organization should it be. But at the end, we have distributed regional offices, and for future Asia, for Asia, actually Japan is the responsible organization and pushing forward. The fourth difference will be we try to find the solutions for urgent and concrete challenges. So that include understanding the changes, how and why is the environment changing, and what will it mean for the Philippines and the world. At that time, Philippines was working on the Inland Sea Program, and was trying to raise some fund. And actually, James Tech was responsible for funding this SIMC program, and we want to reduce the poverty and hunger. How can we elevate billions out of poverty and hunger and still preserve a healthy Earth system? Actually, that really related to the distribution of wealth. People always said, we want to reduce poverty, but we never wanted to say that we should limit the super rich and distribute some funds annually. And that's really a very important thing. Make us more resilient. How can we make cities and communities less vulnerable, more resilient in the face of climate change and extreme hazard? So those are the differences. And ultimate difference is action and transformation. There's just knowledge. We want to make connection between knowledge to action. And so producing knowledge is no longer enough. It must help to spark decisive action. I remember one of my friends, Sherry Roland, after ozone whole problem was solved, he would say, what's the good for science to understand what's going to happen? And you sit idle and see what is happening without taking action to do something about it. So we did say that the huge Earth said produce knowledge is no longer enough. It must help to spark decisive actions. And what Japan can do, that was a discussion when Future Earth was established. Create a visionary path towards sustainability because Japan has an incredibly rich tradition and wisdom, and ancient wisdom for managing water, elite science and technology base and capabilities. Japan has an enormous number of very capable people here, and energy efficiency was the best. Tons of carbon dioxide produced for every 1 billion GDP. Japan is the lowest, 1.0 at the time. It was 204 when we are talking about global change program. And if you look at the modeling of climate system or monsoon in Asia, I think this slide is from Yasunari Sensei from Institute of Humanity and Nature in Kyoto. And also in the our case, they're good modeler, doing excellent modeling of the climate. The Asian monsoon climate system underpins the ecosystem services on which the livelihood and well-being of billions of people depend. And Japan has done very well. At the time, Future Earth in Japan has a Future Earth National Committee and Science Council of Japan. Professor Onishi was the president at the time. And Kasuga-san, sitting there, was the vice chairman of the National Science Council. She was very active in the Future Earth program. And Research Institute of Humanity and Nature University are all involved. But the governing structure of Japan certainly has changed since that time. But Future Earth will depend on Future Asia. Asia is really, economy is expanding, and CO2 emission is increasing tremendously. And so, future Earth will depend on future Asia, and Japan is ideally suited to take a leadership role within Asia and globally. And actually, Japan did take the responsibility and moving forward. And Kasuga-san was a remarkable person. This is the new organization, the governance of Future Earth. You can see it's become more complicated. We have a governing council, an advisory committee, executive directors, the secretariat, global hubs, and there are many hubs in Montreal, Paris, Stockholm, Tokyo here. And the person who is responsible to this Tokyo hub is Professor Dr. Kasuga sitting here. We have regional entities, and it has really moved forward quite a bit. And now we have an advisory committee of Future Earth. Those are the people. You must know these two people here. And Yasunori-san, I know him for quite a long time. They are really very important people. And these two are the chairpersons. This committee member really are very important. And there's something I want to mention is really there are noteworthy achievement, and they did lots of work. Oh, that was a ICAG meeting. That's me. Kasuga-san put me in there. I didn't know, but Urban Planet and other programs moving on very well. And other things, recent noteworthy interface between science and policy and collective message delivery to global leaders. And sleeping financial giants, opportunity for financial leaders for climate stabilities, because in order to make things happen, we need to finance the project, and financial leadership participation is extremely important. And the other thing is exponential climate action roadmap, Future Earth co-design with stakeholders, has shown the pace and scale that action impact. And actually, when we're looking for solutions, we reduce the CO2 emission. We say we have to follow the carbon law. What do you mean by carbon law? Every 10 years, we have to reduce the emission by a factor of 2. And so really have to have an exponential reduction in the carbon emission. More integrated and systematic input from science. You are going to listen to 3 lectures later on and touch upon those things we mentioned here, and like science-based targets, network, and other things. But all those activities, the Future Earth, what ICSU has been promoting, did some good thing to the UN activities. And 2015 was one of the exciting years. I stepped down from the ICSU immediate past president in 2014 and was looking at the future of scientific community and what could we do. And in 2015, in September, when UN announced that the establishment of Sustainable Development Goals, and 17 of those, I was excited that the UN seemed to have waken up. Political leaders have awakened. But when I saw the 17 listed, I was somewhat surprised. Usually when we teach our children, remember 5 things, and then said, 5 things you have to remember. So you ask him, what are the 5 things? When you list 17 things, you're talking about poverty and water and all those kind of things. And people don't remember and miss the focus. One thing, for example, you look at the number 4, quality education. In 4.1 said by 2030, ensure that all girls and boys complete free, equitable, and quality primary and secondary education, leading to relevant and goal for effective learning outcomes. We thought of 2030. 2030 is a long time ahead of us, but think of it. At 2030, those students will be graduated from the secondary education. Where are they this year? This year should be in the elementary school, the first grade. And you look around in South Asia and Africa, we are not accomplishing that. And how can we expect by 2030 all the students will graduate good quality education free? And that's not possible. But we want to dream and make something happen. But actually, in 2015, toward the end of the year, when COP21 talked about deep decarbonization, at that time I felt, yeah, at least out of these 17 targets, UN realized one really important thing, that is the global warming and climate change. That meeting came up with the following conclusion. What is at stake? A binding global climate agreement that commit to 2 degree centigrade limit. And then there's a footnote, preferably 1.5 degrees. 2 degrees is really horrible. So 1.5 degrees. And a clear and concrete pathway toward zero emission by 2050 or 2070. And many countries did submit the pathway to reduce the carbon dioxide. But even if every country followed that pathway, temperature will rise more than 3.7 degrees or so. And many countries are not following it. The number 3 is $100 billion a year to help developing countries beginning in 2020, next year. And that is really should not be a major problem, because economic activity of human economic activity is in the order of trillions and 100 trillions. So 100 million is really a small number of money. And the other thing is achieve equity and eliminate indifference. It was quite interesting. Pope once mentioned in one of the workshops, he said globalization of indifference is something he worried very much, and lots of people become very indifferent about what's going on. So what we have been doing is talking about 17 goals we want to achieve. But one thing we really should realize is humans are changing our environment. And humans are changing atmosphere. And that's the most important thing, what we are doing now. Why is that so important? Because sun is shining, and the temperature of sun is maybe 5,700 degrees centigrade. They emit the visible light mostly, and the visible light will go through the atmosphere, and carbon dioxide and other greenhouse gas will not absorb the visible light. And the Earth, on the other hand, is so cold, about 20 degrees centigrade, emit infrared light. So you turn on the light, we cannot see each other because our body temperature is low. But we emit the infrared on the Earth, emit the long wavelength photons. That will be absorbed by the greenhouse gases and emit backward. So what's happening now is more energy coming in than going out. That's happening every day. Well, more energy coming in than going out. The consequence of those are temperatures rising. Global temperatures rising, although slowly, but temperatures rising. And if you ask many scientists working on the global chain, they will certainly tell you we are in climate emergency. We are really in climate emergency. Look at the unique and threatened systems. That's the result of the research done by 2001, 2009, 2014, and 2018. the temperature rise will cause some problem. Undetectable, moderate, and high, and very high. And so, if you look at the extreme weather events, 0 is the before Industrial Revolution. We are up to 1.1 degree from the Industrial Revolution, and we are in the orange color. It means that the extreme weather event is moderate. We are moving into very high. As all of you have seen, in many parts of the world, like forest fire or Japan, you see typhoon going through last year and this year, getting worse and worse. And even the large-scale singular events is getting pretty possible. It means temperature rises, CO2 methane emitted from the ocean, from methane class rate, or because of the forest fire, emit more and more greenhouse gases. And suddenly, we move from one state to the others, and big change. And we'll not be able to put it back in the next 200 years. Even the ocean rise for several meters. It will take thousands of years before the ocean level could come down. So what we are saying is, we are in the climate emergency. We are already here. And we said, not go up beyond 2 degrees. But 2 degrees is really not acceptable with a unique threatened system or extreme weather events or large-scale singular events. It's really not acceptable. So it said preferably 1.5 degree. 1.5 degree is really not good at all. So we are in an emergency. We really need to change. We need to change quickly. Otherwise, our grandchildren and their children may not forgive us for destroying Earth and their future. Actually, when we talk about our grandchildren, actually, our children are facing it. We are facing it all together at the present time. So, in summary, I would say politically, this is a global problem, need of global solutions. For example, you look at Southeast Asia. Look at the development of the last 50 years. Every country, like Taiwan, get fossil fuel energy from the global market, and you burn it, all those exhausts will go to the air. But that, we cannot do it anymore. If many European countries, Japan, US can do it and use clean energy, it will not be good enough unless we globally complete the transformation. So this is really a global problem. Need global solutions. That's really important. We, young generation, pick up the cell phone and connect to anybody in the world. But that's really not enough. We really need to politically make a global governance or find global solutions. The other thing is, we're talking about sustainable development. We always talk about development, and that development is a big question. How much we need? How much we need? Brundtland, in Rio meeting 20-some years ago, he said the sustainable development is to satisfy our need and will not compromise the need of the next generation. But what we really need 10 kilowatt or 2 kilowatt, and that we really have to examine. So socially, we must turn away from the path of the overdeveloped societies. Technologically, sun is giving us lots of energy. So we must learn to store, transform, and share energy from the sun. And that is really very important responsibility for science and technologies. And I'm glad that I have a chance to come here to discuss with you all those problems. But we are in emergency. We really need to change. We really transform our society to make it sustainable. Otherwise, our children, our grandchildren will judge us one day, about 2050, said, how come? Why you are handing us such an Earth system which is not acceptable? So I stop my talk here. But thank you very much.